All right, only 27 people are here. What happened to the rest? Okay. Can some of you show me your screen? I mean, show me your video. I want some feedback. Yeah. All right. So finish this thing. I won't be checking anything which comes after 10:50. All right. I won't be checking any answer sheets which comes after 10:50. Maybe I should say that. Okay. Now we are going to do the chapter 2. Chapter 2 is about data abstraction. In this chapter, we are going to do we are going to see how to build complex data structures and things like that. Yeah, in Lisp, in Scheme, and we have already noted that in Lisp there is only one basic form to create anything, which is list. So the main construct by which you will create any list is by means of tuples. Okay. Tuples. Now, how do you make tuples? If you want to make a tuple, you use the cons function. Cons 1 and 2 will give you back the tuple which contains 1 and 2. Cons 1.
Your
Yeah.
screen is not visible.
Oh, so then I thought everybody was watching my screen. Okay. Yeah. Thank you, Saina. Yeah. Somebody else also, please unblock your, I mean, show me your video. Yes. Jared is also there. Okay. Thanks, Jared. Okay, so what I was saying is that in C, how do we make a linked list? We make using again tuples, because in C the way you make tuples is by means of the struct keyword, and in struct keyword you say that the first element of the tuple is this, second element of the tuple is this, third element of the tuple is this, and then you use the struct keyword to build larger and larger tuples. So tuples and lists are present in many languages, especially in functional languages or in languages like Lisp. Tuples and lists are the fundamental data structure. Okay, so I already told you that if I want to make a tuple which contains 1 and 2 elements, 1 and 2, 3 and 4 and 5, I just use cons 4 and 5. That will give me back a pair which contains 4 and 5. Now, if I want to get back my first element of the tuple, I say char. So let's take t is equal to, or p is equal to cons for 5. It gives me back, oh, sorry. I'm just getting back to my Haskell notation. Cons for 5. Okay. So now p is actually 4 and 5. The tuple which contains 4 and 5. Now if I say char of p, that will give me back the first element of the tuple. And if I say cudder of p, it will give me back the second element of p. Okay. So char stands for, char and cudder are the historical names. When John McCarthy, the originator of Lisp, when he was programming Lisp, he was using a computer called IBM 704. And IBM 704 had, just like our IEEE, I mean, our modern Intel processors, IEEE, this IBM 704 had a number of registers. Like the Intel processors are the EAX, EBX, ECX, EDX, accumulator and all these kind of registers. Similarly, IBM 704 had many registers. One of them was address register, another was CIR stands for contents of the address register, and CDR stands for contents of the decrement register, decrement part of the register. Okay. Anyway, so the name stuck. Even though we are not using IBM 704, we still use the same name, just using the same char coder. But Lisp, I mean Haskell and other programming languages uses in Haskell, how do we write a tuple? Yes.
Here's what I found.
So for instance, I say t is equal to 4, 5. And how do I get the first element? I just say first of t and second of t will give me back the 4 alpha. So the tuples are present in almost all languages. Python it's there. And yeah. Okay. So that is what is char and cutter. Now, how do we use tuples to make list? How do we make tuples to make list is by a list will always be, so in C, how do we make tuples to make list? The tuple which we will have is 2 elements. One element will be an element. Second element will be a list, isn't it? That is how you make a list in C. You will say the first element of the tuple is an element which holds a integer value or some value, and the second element is a pointer to a list. And now pointer is something which, because in C you are actually confusing between the implementation details and the real underlying data. That's why we have to do all these pointers and all these things. But if we disregard the pointers part in C, when we write a list, the first element is an element and the second element is a list. And for the last element, it will be an empty list. You are pointing to a null list. Yeah. So similarly, in scheme, the empty list is quote pair. Okay. The empty tuple is an empty list. Okay. So that's the empty list. Now, how do I make a list which contains 4, which contains 1? I just say I take an element 1 and I take the empty list and I const them, and I have a list which contains 1. Okay, I have an element 1 and an empty list and I const these two things. So let's put it as define t const 1. Okay. Now
from list, the procedure list.
Yeah. Pardon?
There is a procedure list, no?
Yeah, there is a procedure list which is built on top of this. Okay, I am building it from bottom up. You have a procedure called list. You build the list, which is a easy way, but I'm just saying how to make list using tuples. So now if I say cons 2 and the previous list, cons 1, and this will give me back the list which contains 2 and 1. And if we do cons 3 and cons 2 and cons 1 of, this will be the list which contains 3 to 1. Okay. And one more thing. So if I have, let's say, define t cons 3, cons 2, cons 1. Okay. Now if I say t, this is 3 to 1. Now what will be char of t? What will be char of t?
3.
Char of t will be, sorry.
Parenthesis.
char of t will be 3. What will be cadre of 3? Cadre of t.
1.
Now it won't be 1. It will be the list which contains 2 and 1. Yeah, because when we make that list, the first element is an element, the second element is a list in any tuple. So if I take the car, it will be an element. If I take the cadre, it will be a list, because that is how we make list. Okay. So in other programming languages like Python, you have two separate constructs, one for creating list, one for creating tuples. But in Lisp, there is only one thing, which is this char and cadre to make tuples, and using the tuples, you create the list. Okay. And the way we have constructed that list is by actually nesting tuples inside tuples inside tuples. And therefore, when you take the char, you will get elements, and when you take the cadre, you will get tuples which contains tuples which contains tuples. And such kind of tuples we call list. So if I take char of t, it will be an error. But if I take char of cadre of t, it will be 2. Because char will means that, I get the element 3, and then I can no longer take, it's not a tuple. When I take an element 3, it's not a tuple, so I can't do char of cadre. But when I take cadre of t, it's a tuple again, then I can apply char. So I'll get 2.
It's 11 o'clock.
Actually, I can actually do it as cadrt, which will be t. What does that mean? Cadr, char of cadre of t. In one word, you can say cadr. So what should be caddr? What should be caddr? What does caddr mean? Yeah. What should caddr mean? Anybody?
Char of cadre of t.
Yeah, char of cadre of t. And in this case, t is the list into 1. So char of cadre of t will be what? It will be the element 3. No, it will be the element, sorry, 1. 3, 2, 1. So it will be the element 1. Yeah. Clear? What is char and cadre? Okay. So now, actually, in the first chapter, we have seen that there is something called lambda. Anybody has any trouble with lambda abstractions, lambda procedures and things like that? Anybody? Okay. So the point is that list, you don't need any extra things to implement list. List could be implemented using just functions. Okay, tuples could be implemented using functions. Let's see this. So I'm going to define my own cons function. Okay, my own cons function. So I'm going to say my cons of 2 elements. I'm going to define a new function, my cons. So cons function, what does it take? Cons, what does it take?
2 elements.
2 elements x and y. So I'm going to define my own cons function. So I'm going to define it as a lambda function. Okay, so I'm going to say my cons is a function which is lambda, and it takes 2 elements x and y. Okay, and what does it do? I'm going to say no, I'm going to define it like this. I'm going to say my cons is a function x and y, which is a lambda function which takes an element z, and if z is true, then it returns x, otherwise it returns y. Okay, what does this mean? I'm going to say cons is a function which takes two elements. mycons is my own function, which takes two elements, x and y. And what is that function return? That function returns another function, which takes an argument z. And if z is evaluating to true, it returns x, otherwise it returns y. Okay. So basically what am I going to do? What am I doing? mycons function takes two elements and returns me a function. In that function, I am embedding x and y. And that function does is it takes another value z. And if it is true, then it returns x, otherwise it returns y. And I'm going to define my char of, let's say, z or p is, what does my char of p should do to return me back the first element of p? mycons returns me a function which takes an argument z and applies truth, it's a Boolean value. Z is a Boolean value. And if it is true, it returns x. If it is false, it returns y. So what should my char do? My char of p, it gets this lambda function. What should it do to get p back x? Any idea? If I apply p, if I apply true to p, what should it return? Let's say define t is equal to mycons of 1 and 2. Okay, if I say t true, what will it be? It will be 1. Anybody understand what is going on? Any questions? Jared, you understood what I just did? No. Can you ask me some question?
How do you get this? So T you're just executing, so and then you're saying that you're passing a true, a Boolean true value to
Yeah.
it. So it is.
So I am basically giving one way of implementing cons and char without just using functions.
Okay.
Okay, because cons and char, cons, char, cadder, we think that it's about some data structure, so you need some struct and all these things. Yeah, I'm just saying that you don't need any extra things. We can just use whatever we know already, which is just basically functions to implement cons, char, and cadder. So what is my cons function? It just basically returns me a function. When I apply true to it, it returns me the first element. If I apply false to it, it returns me the second element. And my char function is just applying true to it. And my coder should be what? My coder should be applying false to it. Yeah. Is 2. Okay. Now this implementation has a slight problem in the sense that when I nest it, it won't work exactly like I imagined. If I say mycons 1, mycons 2, 3, and if I say my char of t, giving is back 1. But if I say my coder of t, it will tell me that it is a procedure. It doesn't know how to display that. So what I just did is that I defined a t, which is I put this function twice, mycons 1 or mycons 2 and 3. So when I do my char of t, it gives me back 1. When I say my coder of t, it gives me back, tells me back it's a procedure, because it is my coder actually returns this function, the second element y. In this case, it's a function. Okay. So if I want to print it, I might have to do extra stuff. But it's but you can always extend your code so that you can you can implement char and coder using these just using lambdas. Okay, and so yeah, so in this chapter what we are going to do is that we are going to define uh, all the a lot of data structures using char, coder, and cons. Just basic linked list. Core and char and coder and the cons are basically, yeah. Let me also tell. You can also say list of 1, 2, 3, 4, which will give you back a list. You can also put backward 1, 2, 3, 4. You put backward before anything, it's a list. Okay, so if, for instance, if I do char of, it's also a list. When I put backward char 1, 2, 3, it's a list. Okay, you put backward before anything, it's a list. Okay, so this one is a list, and so is this one. And also you can use, what I was saying is that you can also use the function list 1, 2, 3, 4 to also form a list. Okay, if you do cons of 1, 2, 4, what will be the answer to this? Cons 1 of list 1, 2, 3, 4.
List
So
1,
1,
1, 2,
1,
3, 4.
2, 3, 4.
Yeah, list 1, 1, 2, 3, 4. Okay. All right. So for the Tuesday's class, you read you read this you see this slide 5, lecture 5, data abstraction. Okay, you watch this and come for Tuesday. Okay, so in this chapter what you're going to do is that we are going to use this list which we have just seen to make rational numbers and to do operations on last rational numbers. Okay, all right. Okay then, thank you. I will also try to check the thing by Tuesday, the quiz. Okay then, thank you.
Thank you, sir.
Thank you.